So I think we're ready to go ahead and get started. So our first talk is going to be by Tim Gleason, and he is going to talk to us about buying your first telescope. So here is Tim.
I'll try to talk nice and loud here so everyone can hear me. If at any point you can't hear what I'm saying, just yell at me. I was a teacher. I can take the abuse. So, yeah, I'm just going to talk to you guys about buying your first telescope. I work at Penn State in the Office of Science Outreach, which means we do a lot of things like Science U summer camps, some after-school programs, stuff like that. And one thing that we always end up getting calls about, or at least hearing about from the astronomy department, is people who have bought their first telescope or have found a telescope in their closet, but really at this point have no idea what to do with it, or at least want to get one and want to figure out what they should be getting. So I figure I'll just give you guys some pointers, some tips. If at any point you have a question that's about what I'm saying right then, just kind of wave me down and I'll try to point at you. And there will be some time for questions at the end as well. All right, sound good? Cool. Okay. So there's a couple common situations that we end up seeing here. One of the big ones, we get emails all the time. So Christmas is coming up. I know my kids like telescopes, or they like going up to the rooftop of Davy Lab. Maybe they've been to Astrofest. But if they're going to be getting a telescope, what should we get them? And another one is just, we got a telescope, we took it out of the box, we set it up, I can't see anything, something's upside down, what's going on? So we'll go ahead and try to fix some of those situations here. So, a few things first to look for whenever you're going to be going out and getting yourself a telescope. These should be pretty common sense, I'm sure. But you always want to try to limit frustration. I know personally, so my mom and dad, mom's back there, hi mom. So they got me a telescope whenever I was like about the year 2000 or so. And it was really cool. We took it out, we saw Saturn for the first time, but then we didn't really know a whole lot about how to use it past that point, and it kind of sat in the back, getting dusty for a few years. And it took a long time before we got it back out again. Reason for that is just, it's kind of hard to set up. So trying to find yourself a simple telescope, something that you'll know how to use, is really helpful. And also make sure you get yourself a nice one. It's really tempting whenever it's like, the week before Christmas and you went to Walmart and you see these ones for like $30 out there. It's tempting to buy one of those and say, hey, I know that this isn't too much of an investment, we should try this one. That ends up giving you a lot of frustration. I'll describe some examples and some stories later if you want to hear them. So just first, a little bit of basics about how telescopes work and what you should be looking for in a telescope. So there are two basic types of telescopes here. One is a reflecting telescope. Reflecting telescopes use mirrors. So they'll generally have a mirror at the very back, and that mirror will then have light goes in, hits the mirror's curved, comes to the front, hits another little mirror, comes out to your eyeball. Example of a reflecting telescope would be like this one here. This is a big Gobsonian telescope. We have a very similar one up on the rooftop at Davy Lab that we show people all the time. Nice things about those is they tend to be less expensive. That's not always true, but for the most part they're less expensive because it's easier to make mirrors than lenses. And they also tend to be a little bit more durable. So the one that we have on the rooftop at Davy Lab, I know I've dropped a few times or kicked it around a little bit, and so far it's doing all right. You can realign it. It's a little bit harder to break than if you have a piece of glass. Now compare that with refractors, put that up there, then those use lenses to reflect light. So they'll have a big piece of glass up at the front, and then that will bend the light until it comes down to an eyepiece. And an eyepiece is just this complicated little piece of glass that you have here, and those turn into an image that your eye can actually interpret. So a few other things to know, besides just reflectors versus refractors, the type of mount really matters. In other words, what are you putting your telescope on? So there are three kind of main types. There's more complicated ones, but we'll go over a few here. There's equatorial mounts. So these ones are the ones that are kind of complicated. You might have seen, if you've ever been up on the rooftop of Davie, if you haven't, I'd recommend you stop by some clear Friday night. We always have telescopes open there, and you can check these things out. But some of our big telescopes are this type here. They track the sky perfectly by just moving one little knob. The problem is you have to tell it how to be aligned first, and it can be a little bit complicated trying to set those guys up. That was the first one that I got, was something like that, and you have to align it to the North Star pretty carefully, and there's a lot of little knobs and things that are easy to mess up, especially for kiddos. Compare that to ALT-AZ, which I think stands for altitude azimuth, if I'm not mistaken. Those are just ones that instead of sweeping across the sky and tracking the sky, those just go right, left, up, down, and you can just kind of point them where you want them to go. The nice thing about those is it's easy to set up. You just plop them and then you just move them around. But whenever it comes to actually tracking something, then that's a little bit more difficult. The sky moves as the night goes on, and your telescope might be sitting there and looking at the right object for a moment, but you tell your kid to look, and then they look through it and they say, nope, it's gone. That's always a problem that we have whenever we have like Astrofest or something, trying to keep these telescopes aligned. So we tend to like the first type a little better. Another type of mount is the Dobsonian. That's this one here. This is the easiest type of mount that you can have. You literally just push it where it wants to go. It's really easy to do. It's really hard to break. And the nice thing about Dobsonians too is you can get fairly big ones for fairly cheap. There's none of this complicated hardware here that you're paying for. Instead, there is just a big piece of plywood down at the bottom and a couple of springs that hold it up. The problem with that is there is absolutely no tracking, and depending on your setup, everything looks switched left to right and up and down. So you're looking through the telescope and then you're trying to push it, but if you push it forward, it actually looks like you're going backwards, and up is down, and it's all a little bit complicated, but you get used to it eventually. The problem with telescopes, and I don't know if any of the other astronomers in here have ever had this issue, but now I'm used to the fact that whenever you look through there, you push it one way and it goes the other way. So now I do things like if I'm on my bike, I have to think for a second and not turn the wrong direction. But besides maybe messing you up that way, they're really easy. Now, another thing about telescopes that kind of scares some people away is just seeing, let's say you go to a website and it has all these different statistics, all these different measurements of what are some of the different qualities of this telescope. And without any real description, it's kind of hard to know which one's best. There's three numbers, really two numbers and one equation here, that are important. First one, aperture. So your aperture is just how big is the telescope. This one is what they just call 8-inch aperture, which means this front part here, where the light actually goes in, that's 8 inches wide. So larger the aperture of your telescope, the brighter the images are going to look. If you look through a little telescope, it might have the same magnification as this one, but let's say you looked at the moon, it might look kind of just dim and a little bit blurry, as opposed to a larger mirror, a larger aperture like this, might look clearer and might look brighter. In this case, 8 inches is even a little bit too big to look at the moon. It kind of feels like you put your eye up to a laser whenever you look through that thing in a full moon. But it's at least good for planets and darker objects, galaxies, deep sky things. Your focal length is basically it's how much magnification you can get out of it for a given eyepiece. The actual definition is how long it is from where the light starts bending. In this case, with this telescope, let's see if I can just drag this out here for a second and not hit anything too important. So the way this telescope works is light comes in here, goes the whole way to the bottom, hits a mirror, and then it starts bending till it comes back up to the top. There's another mirror in here, and then it shoots out the edge here. That distance that it takes that light from going from being completely unfocused, hitting the mirror, to being focused down, that is your focal length. And in general, the longer your focal length is, the more magnification you can get out of a telescope. And then there's focal ratio, which is just the ratio between those two. So this tells you how bright an image will appear. You could have a telescope that was super long, had a super long focal length, high magnification, but images might appear really dim, as opposed to if you had a larger telescope like this that had a faster focal ratio, then things are going to look a little bit brighter. Now, generally, that's not something you need to worry about too terribly much. Any reasonable telescope is not going to have a crazy out there focal ratio. It's mostly used for photography and stuff, so you shouldn't have to worry about that one too much. A few other things to consider whenever it comes to actually buying your first telescope. One is portability, and this is one that people don't really think about a lot.
It's I've seen people before who have bought absolutely massive telescopes, thinking, "Oh, this looks awesome." And every time you go to a web page and it says like, "Oh, here's the 8-inch one, but for $100 more, here's the 10-inch one. Oh, but for $100 more, here's the 12-inch one." And people kind of forget, wait a second, there's such a thing as too big of a telescope. An example of that, a few years back, my wife and I were going out to this house where there was somebody who said, "Hey, I have a telescope. Does the astronomy club maybe want this telescope that I happen to have?" And we're like, "Oh yeah, sure, we'll take a telescope." We get there, and I'm glad that we took the pickup truck, because it turns out it's a 14-inch diameter Dobsonian. 14 or 16? 16-inch Dobsonian, thank you. So twice as wide as this one. And it would not have fit under the, oh, did I? Whoops. Can you fix that for me? Oops, thanks. So it would not have fit under the roof here. In our apartment, we even had to keep it down at an angle. It's probably about 12 feet long or so. That one did break down, where you could actually unscrew it and take the parts places. But still, consider that whenever you're buying a telescope. If you don't get a telescope out, it's not really of any use to you, no matter how big it is. Same thing with how easy is it to use your telescope. If you have that same frustration factor where you end up getting your telescope and then it's so complicated you can't set it up, or you get like a really complicated one with tracking but you don't really know how to find the North Star to set it up in the first place, that can be hard. So it might be better to get a simpler, smaller telescope at first. Not necessarily cheaper, but at least smaller and easier. And then after that, go ahead and get yourself a larger, more complicated one. And also quality. I'll have some more stats about that in a second. But in general, if you bought one off the shelf that was $30 and has little plastic eyepieces, you're going to end up with a lot more frustration than if you just went and got a nice one that has a decent set of eyepieces that come with it. And there's a lot of good places on the internet. I'm not like going to particularly tell you that any one site is better than any other, although Ryan is pretty good. But Celestron, there's others that have some really nice telescopes. So go for a name brand. And a few things to look for that probably are not so great. If you have I'd say at least most telescopes like this, most big reflectors, you can put either 2-inch eyepieces or you can put 1.25-inch eyepieces in there. That 1.25 inch is just showing you the diameter right here. And then the 2-inch ones, they're massive. They weigh like 3 pounds sometimes. They're absolutely huge. Either of those are pretty good, but one red flag to look for if you ever see a telescope that says 0.965-inch eyepieces, those tend to be the smaller ones, the little plastic ones. Those are the ones that you tend to see at Walmart. And I wouldn't recommend getting that. I've had a couple people come up with little kids who are saying, "Hey, check this out." What? How do I keep doing this? Is it on now? Yay. I need to stop touching it. So I've seen a lot of kids come in and they try to set something up, but it's one of these 0.965-inch eyepiece ones. They tend not to be so great. And also watch out, and it's kind of small. This one says max power on your telescope, 450 times magnification. You're not going to get 450 times magnification out of our telescopes up at Davie. You're definitely not getting it out of one that was $30, like the one I found here. That tends to be if you put in a super high magnification eyepiece into the thing, everything's just going to look blurry, and it's not really going to be worth it. And then I just threw in an angry review down here because it's amazing how many of them you can find whenever you look at some of these. And it's always the same sort of thing. I bought a telescope. It turns out that we can't use it, or everything's upside down. Turns out if something's upside down in a telescope, that's not necessarily a bad thing. Some of them just work like that. That doesn't mean it's broken. But if you can't see anything at all, or everything's really blurry and doesn't get fixed, it probably means there is something wrong with it. Or you can always just bug the astronomy department here, email them, and they'll probably forward on to one of us. And I've helped out a lot of people who have had issues. And sometimes it is just something simple, like, oh, turns out there was a piece of paper at the bottom of the tube. We got to figure it out. So just let us know. That's what we're there for. All right. I don't remember if I have any more slides. So a few things you should look for. These are my personal opinion. This is not going off of any sort of facts or hard data. But it seems to me like people that I've seen who've gotten telescopes that are in the $200 to $500 range tend to be the happiest. You can get some that are cheaper that work out okay. As a sense of scale, this sort of thing would be about $400, and it's done everything I wanted it to except for taking pictures through it. So that's probably about the range you want to look at. Also, make sure that you check out the reviews. The great thing about the internet today is that there's an awful lot of reviews out there of people who have tried this, and they're probably in the same boat as the rest of us. Don't really know a whole lot about scopes. I just want to get something for the kiddos or for myself. And if it is for a kid, I'd really recommend something like this. Up on the roof of Davy, whenever we have kids there, it's really easy for them to like accidentally bump something just a little bit, and suddenly you can't see anything. You have to realign everything. It's a lot easier just to grab the telescope and go like that than try to realign the entire thing. So you might want to consider some sort of simpler mount like that. I think I may think of this here. That's it. So does anybody have any questions or want any advice or anything? Oh. Questions? Okay, right back there.
Did I hear you say that on every Friday night?
Yes, so one thing that we always try to get out to people, there's Astrofest, which happens over the summer that a lot of people are familiar with. It's over the Wednesday, Thursday, Friday, Saturday night of Arts Fest. And we have the rooftop of Davies open. There's all sorts of activities and stuff. But also, most clear Friday nights, up on the roof of Davy Lab, we have telescopes that will be open. Either there will be people from the astronomy department, grad students and such, or there'll be people from the astronomy club who are up there who will happily show you things through the telescopes. Especially during the winter months, it is not very popular. So if you've been there during Astrofest, whenever you're like shoulder to shoulder with everyone on the roof, that's kind of miserable. There's probably just a few students up there waiting to show someone something through the telescope. Just check out the astronomy department website. I think there's a corner that says stargazing. You can click on it and it'll show you the status that night to let you know if there will be an open house or a planetarium show or something. Other questions? Yeah.
That upside down thing.
Yes.
Right? Is there, some telescopes aren't upside down?
Phew. There are telescopes that end up being upside down. There are some that are not. And I'm trying to remember exactly what the names are of each. Michael, do you know off the top of your head? I'll put you on the spot. What was that? All right, so those are the ones that at the end it like comes up part way, right? Mm. Okay, so you said Galilean refractors? Is that what they're called? Okay, those are the ones that will give you right side up. I think you can also buy, you can put prisms on there, and those will put it right side up. Those just go at the end, and those will just change the angle of it, flip it. It's in the end of the telescope, kind of. You would end up putting it right about there. Yeah. Other questions? What was that? Sorry, what was that?
You lose light.
Oh, yeah. So one thing to point out here is you don't necessarily want that because you are going to lose some light. Every time you put something in the way of your optical path where the light is coming through, you're going to lose at least a little bit of light. Now,
But then it's easier to scan the neighborhood.
yeah. Sure. I don't know what you're doing with your telescopes, but it's easier to do. It is easier to use, especially if you're doing daytime viewing. If you want to look at birds, it's very disconcerting to watch the birds upside down on the lake. What else? All right. Thanks, guys.